Hi everyone, and welcome to lesson number 6 on parallel circuits. And so today, by the end of today's lesson, you're going to understand that parallel circuits have two or more paths. So before this, we learned about series circuits, and we know that series circuits only have one path or one loop. Okay, but in parallel circuits, you're going to have two or more paths. This means that devices can be controlled individually. That means one of the devices can be on, one of them can be off, one of them can be broken, one of them can be working, but then whatever's remaining will still work. Okay, we know that from series circuits, like with the example with the Christmas lights, if one of those Christmas lights in a series circuit uh, blew out or burnt out, then the whole line of Christmas lights would all go out. Okay, and the last thing is that in a parallel circuit, each item gets the full electrical pressure. And this is obviously really useful because even if you add more bulbs in parallel, each of them will have the same original brightness. Okay, and so those are the main things. So if you ever get a little bit confused, please just come on back to this summary at the very beginning here. Okay, we're going to do a little bit of a Phet simulation as well, just so that you can see the difference between series versus parallel circuits. And then after we've reviewed everything and you've maybe practiced a little bit on your handouts, please click on the link for the quizzes assignments on parallel circuits. Okay, a reminder as always, sign in with your TTSB email account. Okay, so just a warning everyone, I think this is going to be a long lesson, so please just bear with me. Feel free if you need to, take a break in the middle of the lesson, okay? So take a breather whenever you need to because it's probably going to be a little bit of a long one. Okay, so here we have a picture of parallel circuits, right? We've got a microwave, we've got a toaster, and we have a kettle, okay? What you'll notice is that each one of these can work individually. They don't have to be all on or all off. That's because each of these are on individual parallel circuit loops, okay? So a parallel circuit, it's a hookup in which the current has more than one path. Okay, sorry, when we're starting on page 135. Hope that's clear. Okay, so what is a parallel circuit? You walk into your home and switch on the TV. You switch on only the TV. You don't have to switch on the toaster and broiler, the hair dryer, and all your lights. You don't have to because your home is not wired in series. Your home is wired in parallel. There are two important facts that you should know about parallel circuits. In each parallel circuit, the electrons have more than one path to follow. Each appliance has its own path. This lets you use or shut off only one appliance at a time. Okay, that's really, really important. It would be very silly if, our homes and schools were wired in series because it wouldn't make sense that you had to have them all on or else they would all be off. Okay, in a parallel circuit, the appliances do not share the electrical pressure. They get the full pressure. Each appliance gets the full voltage it needs. Adding more loads does not weaken the force. Each load still works with full power. For example, adding more light bulbs to a parallel circuit does not make each bulb give off less light. Parallel circuits make sense for use in homes, schools, and factories. Okay, so let's do a Phet simulation practice just so we can see what this means. Okay, so we're going to explain this over here, but I think seeing is believing. So click on the link. Okay, click on play. We should be pretty familiar with this if you've been following along. Okay, and so first I'm just going to construct a series circuit. Okay, so I'm still going to use two. I'm going to use two batteries. Let's just go like this. Okay. So please feel free to follow along with me. Do whatever you feel comfortable with. Either watch while I do the whole thing or watch while or stop and pause this, right? And then follow along. Okay, so I'm going to do two of these side by side just so that you can see the difference. Okay, so let's do another one right here. Okay, so these have equal brightness. They are on two separate circuits, right? Okay, so now what I'm going to show you is I'm going to break this right over here, okay? And I'm going to put in two light bulbs in series. So just be careful. The right part of this one has to connect with the left part of this one, okay? And then after this, we'll put this together, okay? So what we notice is that when they're in series, meaning that there's only one loop right here, okay, notice that the brightness is not as bright, okay? Everything gets dimmer. Uh, if it's one bulb, it gets the full electrical pressure, okay? Now what I'm going to show you is how to make something with two loops, okay? So now I'm going to go like this, and I'm going to form another rectangle, okay, another loop. Okay, and then we're going to see what happens. Okay, so can you predict what's going to happen based on our notes? What do you think will happen when I hook this up? Will this get dimmer or will it stay the same? Okay, let's see. Okay, and so this is the exact reason why parallel circuits are so useful in schools and factories and homes, because even if I add another light bulb or even a third light bulb, so let's add another one in. Okay, a third light bulb, but I'm going to make like an extra box for it, okay? What do you predict will happen with this third light bulb here? Okay, will it make everything go dimmer or will it be equal brightness? Okay, so equal brightness, still okay. So here what I'm going to do is I'm going to add in a third one over here even, and we're going to see that it even gets dimmer and dimmer and dimmer. Okay, so even less dim. So this is series circuit. This is a parallel circuit. Okay, so here I've taken screenshots. Okay, so in a series circuit, the bulbs get dimmer as you add more bulbs, whereas in a parallel circuit, the bulbs maintain their original brightness even when you add more bulbs. Okay? Okay, let's see something else. What happens if one of these bulbs breaks or gets disconnected? Okay, so when one of these things get disconnected, okay, the whole thing shuts down. What happens if I were to, what do you think would happen if I were to break the circuit right over here, for example? Okay, take a guess. Okay, so there we go. So because each of these electrons have their own path right here, so this bulb has its own path, and then this bulb also has its own path right here, there's actually options for where the electrons choose to go. So even though this bulb is broken, let's just say, the other two devices work. That's why even when, for example, you have a problem or you disconnect your toaster, okay, that's the reason why your kettle still works or your microwave still works. Okay, that is the why parallel circuits are so much more useful, as you can imagine. Okay. Okay, so when you're trying to control different devices in a series circuit, because there's only one path, right over here, one loop, if there's a break in the circuit, they're going to all turn off. So either it's a closed circuit and everything is on, or else they're all off. In a parallel circuit, multiple paths, so in this case here, there's one path, two paths, three paths, okay? So if one of these was broken, because there are multiple paths, it means that the devices can be each controlled individually. Okay, and let me just show you actually, okay? So when I go back onto there, if I were to cut this one, these two would still stay on. Okay, and if I were to cut this one here, it doesn't matter if it's at the front here, there's still another path for the electrons to go through, okay, here and here as well. Okay, so I hope that you have a chance to actually try this out as well. And then I hope that that makes this paperwork more easy because now you've visualized it and it makes more sense. Okay, so let's go through these examples now. Okay, so please follow along with me and take notes down on your worksheets. So how many bulbs are in this parallel circuit? So there's 1 and 2. How many paths does the electricity have to follow? Follow the paths that are shown with your pencil. Okay, so let's mark them down, okay? So I'm going to use red. So the electrons exit from the negative terminal. They go down through here, okay? They have a choice. They can go through this light bulb right here. and then go back. That's one path, and I'm going to use another marker, okay, so that you can also go through here as well. Okay, so this one is actually not going through the light bulb, okay, it's just passing through the wire, going around it, okay? So this is path number 1 in red, path number 2 is in green, okay? So the answer to this is 2. Okay, is the circuit complete or incomplete? The circuit is complete, okay? Everything is on, or sorry, everything is connected, so I'm just going to circle complete, okay? Do the bulbs light up? The answer would be yes. Okay, does the electricity have to pass through bulb number 1 for bulb number 2 to light up? So let's take a look, okay? Does it have to go through bulb number 1? It actually doesn't. Take a look at that. It can actually go around bulb number 1 instead, okay? So the answer to this one is no. And that's why parallel circuits are so useful, okay? So this means if bulb number 2 were to blow out, so even if this one went bad, okay, so this one went bad here and burnt out, would bulb number 1 still stay lit or would it go out? Think about that. Okay, because it still has a path for the electrons to follow. It could still go through here. Okay, so what's the answer to that, do you think? Okay, so the answer to this is that it would actually stay lit. Okay, now if bulb number 1 were to go out, let's take a look. Okay, so instead, let's just see what would happen if bulb number 1 were to go out. So this one is gonna blow out right here, okay? But let's take a look. There's still a path for the electrons to go. It doesn't matter that bulb number 1 was first in line. It actually has the electrons have the option of going around bulb number 1 and still making contact with bulb number 2 and making the circuit complete. Okay, so that's the usefulness of a parallel circuit. Because of the different paths, each of the individual devices can stay lit. If a third bulb were added, bulbs number 1 and bulb number 2 would give off less light or give off the same amount of light. Okay, what do you think? And we saw this, right? We saw this in the simulation, right? Okay, so they actually gave off the same amount of light, right? It doesn't matter if there were 2 bulbs or 3 bulbs, the brightness of each of these remained the same, okay? Same as the original. So I'm going to underline or circle give off the same amount of light. Let's save on some writing, okay? The bulbs in this circuit do or do not share electrical pressure. So they do not share electrical pressure, right? They have the full electrical pressure. Your home is wired in parallel or in series. So we know that they are wired in parallel, okay? In parallel. Okay, let's keep going. Okay, so please feel free to practice this on your own. Okay, I don't want this lesson to be super, super long, but this is good practice because I'm going to choose some of these questions to put into our quizzes assignment. Okay, next up, let's take a look and let's just compare these two. Okay, so over here, what kind of circuit is this? So let's just trace the path. Okay, it has 2 devices. It has a switch and then 2 loads or 2 bulbs, okay? But when I trace it with my pencil, I notice that there's only 1 loop. So if there's only 1 loop, it must be a series circuit, okay? How many paths do the electrons have to follow? I just highlighted it. It only has 1 path. How many loads does this circuit have? So loads means like actual devices that use up electricity. Okay, so the switch doesn't use up electricity, but the 2 bulbs do. So this actually has 2 loads. Is the circuit complete or incomplete? So when I look at it, the switch is closed. So the circuit is complete. Okay, oh, and it says that here, do not count the switch as load. Are the loads working? Yeah, everything is connected, so they would turn on in real life. Okay. If one bulb were to blow out, so let's just say this one were to blow out right here, whoops. Okay, so if this one were to blow out, it's only on one path, right? So this would kind of act as an open switch. Okay, so if one bulb were to blow out, the other bulb would go out as well. Okay, adding another bulb would make the other two give off less light. Okay, so I'm going through these with you just so that you can see a little bit more examples. Okay, this is not a good way to wire a home, right? It's not a good way to wire a home because it doesn't make sense if one device blows out, then they all blow out. Okay, let's take a look at this one here. What kind of a circuit is this one here? Okay, let's just trace this. Okay, so it exits from the negative is over here, I think. Yeah, so let's just go this way. Okay, so it goes around one loop right over here, and then there's also ability to go through another loop here. Okay, so what kind of circuit is this? Well, it has two paths at least, so this must be a parallel circuit. Okay, please copy this down. How many loads does this circuit have? So the loads are the things that use up electricity, so two bulbs. Okay, so there's two bulbs, that means it has two loads. How many paths are there to follow? Two. Is this circuit complete or incomplete? So the switch is closed, all the metal is touching the other metal, okay? So it is in fact complete. Okay? Okay, let's turn the page. Now we are on page 140. Okay, are the loads working from the previous page? Yes, they were. If one bulb were to go out, the other bulbs would give off. Okay, so this is a parallel circuit. So that's just like these ones here. So even if one of them were to go out or added or whatever, it doesn't matter, okay? No matter what, they always give off the same amount of light. Okay, so this one here, if one bulb were to go off, they would give off the same amount of light. Let's just highlight that or underline it, okay? Adding another bulb would make each bulb give off, again, the same amount of light. Is this a good way to wire a home? Yes, parallel circuits are the way to go, okay? Okay, now they're using uh, circuit diagram, okay, instead. Let me just think. Okay, so I'm not going to go into this because this is the same thing except with circuit diagrams, so we're not going to go into that. I think I'm actually going to skip this part here. Okay, so skip the bottom part of page 140, and where you can also skip this part as well. Okay, so skip this part as well. Um, okay, yeah, since I'm not teaching you face to face, I don't want to make things too complicated. Okay, so right now. Okay, this one you can do though. You can practice this on your own. Again, I might use some of these questions in our quizzes assignment, okay, online assignment. And then we're also going to skip this for now. You could always practice this as part of review though, okay? Okay, so actually I think that's it for now. So please make note of what I've skipped and where I've told you to actually practice, okay? And then I would like you, after you've had a chance to review everything, just to go back to the beginning of the PDF, okay? Click on this quizzes assignment on parallel circuits, okay? And use your TSB email account in order to have me directly notified of any of your marks, okay? Okay, so everyone, that's it for today. Have a great week, and I'll talk to you on the next lesson. Thank you. Bye.